Okay, let's look at an example. This one's called Teaching and ADHD, and this article is in your Chapter 11 materials. And I'm not going to go through all this, but we scroll down here. Sorry, I know that's going to flash on you. What they've done is they've given a survey to people, and they're asking them questions about strategies they use in the classroom. And if you can see the survey questions here. And then it talks about the statistical results. So, just to jump over to this one right here, it says, well, one way ANOVA indicates a trend toward statistical significance. However, years of experience are not significant as age in impacting the teaching strategies. Well, to understand what that means, we would want to drop down to their tables, and what we see is, and it was referring to this one right here, the mean scores of methods used to manage ADHD behaviors. So they asked teachers with different levels of experience the strategies they use to manage ADHD behaviors. Because this is not significantly different, this is not less than 0.05, that means that statistically, regardless of the years of experience that somebody has, they use the same methods to manage ADHD behaviors. Now if we roll up, here's the same situation where they have done it by age. So we have 4 categories. So we have 4 groups, 3 degrees of freedom. And they want to know, is there a significant difference based upon the age of people in regard to how they manage ADHD behaviors? This over here is less than 0.05, so we can say yes, there is a difference between the age groups, and we can see what their mean scores are, meaning that the people who are older scored higher on this. What we don't know, and this will come up again, is where the difference is. More than likely, there's not really a difference between 31 to 40 and 41 to 50. We don't really know that, but there is a way to figure it out, and that'll come up later. So if we go back up here, here is a written description. A one-way ANOVA indicates a high degree of significance for this variable, probability of less than 0.05, and it kind of gives you a description to tell you where that differences are. The thing I want to caution you on is this trend towards statistical significance. Remember what I said about significance. It's like pregnancy. Either you are or you aren't. That was not a significant difference, and that's it. That's the end of the story. So that's just a real quick example of what to look for in these. These are really easy to find. And that gets into some other tests too, and we'll come back to this article so that you can see what those are like. So there's an example of an ANOVA. I also want you to go into the discussion boards, and we use this geography article to discuss t-tests, but it also has some ANOVA in there too. So I want you to look at those 5 or 6 questions in the discussion board. Some things that you need to think about is, we talked about the fact that when we use multiple t-tests, things can happen, things can go wrong, and what happens is that adds additional error into the test. Well, if we start adding more and more variables into an ANOVA, the same thing can happen, but it has a built-in adjustment for that called a Bonferroni adjustment. And what it does is it forces this alpha level, this 0.05, up to a higher level to make sure that the differences we see are real differences and we're not making a mistake, which, if you remember, is called a type 1 error. It wants to make sure that we're not saying something that's true that is not. The reason I'm including this is because you'll come across this Bonferroni adjustment. As long as it's still statistically significant, that's good enough. I just want you to be aware of what that wording means. The last thing on this is the difference between t-tests and ANOVAs. The biggest difference is how many groups that you can compare, or how many sets of tests. With a t-test, you can only compare one group with 2 tests or 2 different groups. But in ANOVA, you can compare multiple groups. You can compare freshmen, sophomores, juniors. You can compare age groups. As many groups as you want, you can do that. One thing that's important to remember that a t-test can tell you not only if there is a difference, but where the difference is. For example, if we discovered that there is a significant difference in male and female GRE scores, and that's all we can compare is those twos, the male and the females, well, one's going to come out higher than the other, so we can automatically know which one is higher. The problem with an ANOVA is it only tells us there is a difference. So for example, if we were to look at this and we said that the average of group 1, let's say we're using SAT scores. Group 1 is the freshmen, sophomores, and juniors. Now if we rejected this null, all we would really know is that one of those equal signs went away. The problem is we don't know where the difference is. We don't know if it's between here and here, or here and here, or if it's both. In order to figure that out, we have to do something called a post hoc test, which will come in later on. And it will tell us not only if there is a difference, but where the difference is. So it kind of takes 2 tests to be able to figure that out. So that wraps up the things about ANOVAs. You have a couple of discussion boards to participate in, and an assignment will be coming to you.